You see how many of these are placed here. If I select all, about 33 flanges I have placed. These are the actual planar faces that I got from each and every selection that I had right now. Hey everyone, I'm Bharat, as known as the Indian BIM guy. In this video, we are breaking down one of the most painful yet exciting automation task line by line. If you have ever been stuck with the painful Revit tasks, this video might be helpful for you. You might pick up some points out of this video to automate your particular tasks as well. Remember the previous video that was supposed to take hours? The work that was actually taking hours is now being done in minutes, or I would say matter of seconds, right? But the point is, how does it actually work? In the last video, we automated flange placements on CAM-Duct parts in Revit. Fully parametric, fully custom. But let's reverse engineer it today. Let's get into the Revit straight up. So here we go. Yes. So let's get real. You have get these parts right here where you can see these parts are coming to you without the, all you see here is these are the parts that are coming to you from the CAM-Duct, right? I'm not sure how many of you guys are aware of CAM-Duct, but yeah, even I'm not a CAM-Duct guy, but this was one of the problem that one of the friend came up with, and he's having some workflow which he wanted to automate, and I'll explain you what workflow was it. Right here you see these were the MEP fabrication ductwork, the category for the Revit, right? And these are actually coming from CAM-Duct. The moment it comes from the CAM-Duct, they are supposed to have openings over here for the bolts, but as it is coming through the CAM-Duct, even I'm not a CAM-Duct person, so I'm not sure this cap functionality is there in CAM-Duct or not. But yeah, the friend of mine who came up with this query or the work problem that he was having, so he wanted to solve it inside the Revit only, because at the last of it their workflow goes in a manner where they are bringing it, these MEP fabrication ductwork inside the Revit, and from here they extract different file formats to give to their CNC fabrication machines. So I cannot go into the CAM-Duct and look for things that it exists or not, but yeah, I know that we had a solution for automating it right here in the Revit itself. So that's where, what did we do? Here you go. You can see first of all, I'll break it down line by line, or I would break down the problem. How is it gonna be? What was the actual query? What was the actual problem in real words, right? So here the major problem they were having was no bolts. So they wanted to have the flanges with the bolts, but the moment if you see there are already flanges placed here, so I don't think I could place on the top of it my another family. So before moving ahead, what did I do? You go ahead. The first problem that comes into the picture is, if you go to the edit part, the first one is I need to turn off each and every flange at the back that you see, right? These flanges are supposed to be closed, turned off, or in this Revit terminology these are known as connectors. So these connectors are supposed to be turned off. You can see these are the connectors that are connected over here, and you go to none. Okay, and the moment you go ahead, none. Easy, pretty easy when it is just 2 of it, right? What are you gonna do when there are gonna be about 10 or 12 of it? Because this is actually true. They are over here. You see connectors. There are now about 11 connectors, and here you go ahead and press none for each and every one of it. You have to go ahead with it, and this is the way you have to turn each and every of the connector off. And you see now I turned off some connectors. So this is the first part of my problem, where I have to manually turn off each and every connector, and the moment these connectors are off, now is my time to go ahead and place an actual Revit family over here. But are you even guys ready to do these things? I mean, I definitely was not, because I wanted, if the very first thing, if I get into some automation, then if I look at the workflow, where I have to first understand, is this a workflow to be automated or not? let's be real, because there could be workflows that are not actually even meant to be automated, that are very easy or some even in manual, right? So it doesn't make sense to spend some time on it. But these sort of problems where I understand I have to go ahead and turn off each and every part, yes, this one definitely sounds like a problem to me. Yeah, so I was definitely not ready to go ahead with this. So I'm not sure how many of you would be, but I definitely was not. So this is the first one. The moment we are done with this, where turning off each and every connector, the moment we turned off each and every connector, now we have to go ahead with the second part, where there is supposed to be placement of flanges right over here, right wherever we have turned off each and every connector. After turning off connector, you have to go ahead and set the dia for it, and after setting the dia, you have to arrange the number of bolts, which can be easily tackled with if we have a good parametric family. So that's the same approach we took. But yeah, in terms of that as well, if you go ahead and try to place manual family, you see how you're gonna arrange the families in these orientation. Of course can be done, but again quite tricky, quite time consuming, I would say. And that is the sole purpose of saving the time. The sole purpose of doing the automation is to save some time and enjoy the leisure time, having sip of coffee and enjoying with the friends, right? So why not, let's just go ahead with it. So we actually have a family. I'll show you how tricky it gets to place a family. So I'll go ahead with it. Where is it? I think there you go. So here, very first thing, we made it a face-based family. Here you go. It gets too tough for me to place it. Nope, 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 I cannot. Okay, anyhow, it's placed. But yeah, again, I really don't even want to get into this to arrange it on here. Then I have to set the die as parametrically, and then the number of bolts, all the number of bolts will be adjusted automatically because this is entirely parametric family. I'll show you later as well what we have done in that. So that's one of it. So once this is done, then they'll be more than happy to take this out of the export it and take it to the CNC machines into their formats. So this was the core problem. Let's break it into smaller chunks. First of all, we have already understood what was the problems, right? Now let's break it in terms of our automation. So let's go ahead, let's get it. Oh, here we go. Okay, the first problem is to turning off each and every connection. Turn off every connection. Okay, second one, the moment the connector is turned off, now what I want to do, I want a smart parametric family, flange family. Smart parametric flange family. Done. We have it. Third and the most important part, face based placement. Come on, what am I doing? Face based placement using custom filter, I would say. I'll show you what this custom filter for selection means, because I'll explain you why I'm going for this special custom filter for selection. Let's get started. That will give you more better idea. So for the timing, all the connections that I have turned off, I'll undo that. Talk, talk, talk. There you go. Modify attribute. Done. All right. Now, if we are automating, how can we not talk about Dynamo? That's where all the magic's gonna happen. Let's open Dynamo. Yes, I think Dynamo is open. Yep, this is on another screen. Let me bring it up here. Here you go. And yes, in Dynamo, I'll starting from the completely from the scratch. So understand that I do not even have any template or anything. This is the first process that I'm going with. So I'll share you the template if you guys need. I might be having it with me. Yep, here you go. By what do I mean by template? Template is some piece of code, or you can call it as boilerplate code, that you start to see the moment you open your Dynamo Python node. Here you go. And you see, this is the boilerplate code that already there, but I don't want to use this. So I'll place my own piece of code. This is something that I'll be needing. Okay, tuck. Come on, buddy, I don't need you. All right. So this is something to start with, and along with that, then we might be needing something called as transactions. Tuck. This will make my piece of code complete. And yes, for the time being, as this is entirely a new demos for you, I mean a new breakdown for you, so that's why I did not have it set up. And if you want me to make a special or dedicated video for you to have your own setup where you open this piece of code, open your Python code, and all these lines of code will be already set up for you, do let me know in the comment, and I could make up a dedicated video that will help you in making up and going ahead with the basic setup of your Dynamo for the Python. All right, in order for us to proceed further, we already have the template, and yes, we'll be writing most of our code over here only. And how we gonna write it, how we gonna break it down, we have already seen this into 3 basic steps. So we'll be tackling the first step first, right? What is the first one? Where is this guy? We have to turn off every connection. Okay, seems easy, right? And I'm sure it is gonna be easy. So in order for us to proceed further, the first step that I'll explain you is you have to make sure you have an understanding what you wish to do, right? As right here, I know that I want to turn off these parts, right? These connections, and I can see this is somewhere in my parameters right here on the left. It says edit parts. It shows somewhere here. So I need to have an understanding in terms of Revit API how I can access this property from the API perspective. All right. So in order to understand the tool, or in order to understand the very basic of the Revit API, the very first tool and the very important tool that is always going to be of help to any developer or any Revit API enthusiast, that will be Revit Lookup. All right. So the moment you see this edit parts over here, it looks pretty similar to any way the user will look like. It looks anyway similar to the Revit UI, right? But when I say we have to look into a different perspective, what perspective do I mean? We need to look into a perspective of a Revit API developer or a Revit API enthusiast. What do I mean by from a different API aspects? Now I need to understand what this property is. How can I access this property with the help of Revit API, right? That's where this guy, or I would say this particular tool, which is called as Revit Lookup, is always gonna be of great help to me. Not just to me, it's gonna be a great help to every developer out there, and it still is. So when I say Revit Lookup, this itself is a dedicated tool which is having a lot of functionality, which comes with active UI. You can get the view of active view, active document UI. This is just a dashboard that I've opened for you. If you want a dedicated video on this, I can make it up for you to have a greater understanding of how this Revit Lookup is working. But for the time being, as this one is not about it, so we'll just go ahead and let's understand how can I find where this property lies for me to property or method. I don't know what is gonna give me access to this edit parts. So let's go ahead and edit parts. I'll snoop this selection, the element that I've selected. I'll be snooping it. By snooping means I want to see what this actually brings to me, right? After snooping, I can see more parameters. You see this, whatever you see, these are the parameters. These are actually instance parameters. We already have awareness about the instance parameters and the type parameters. So all the instance parameters that I can see here will be the first parameters that I'll be seeing when I snoop it. And here I can see some properties and method. What are properties and method? We can actually have in-depth understanding the moment we proceed further. So right now I can see all the parameters are right here. Let's go ahead and get into this parameter. So inside this parameter, I can see there should be a parameter called more parameters. All right, do I have it? Let's try to find it. And I'm going the way I'll be exploring it on my own, right? So I'm not sure will I be able to find what I'm looking for here or not, or I have to take a step back. Let's just go ahead and look into it. Okay, more parameters, storage type is none. Okay, all right, definition is fabrication part duct. Okay, I don't think I can see something or maybe any property that's gonna allow me to set it right here. So let me see where I can find it. It's not here. Okay, that's totally all right. Then we'll go ahead. We have two of the connections, right? So let's try to look into that way. Mm, mm, mm. The moment I come down, I see something called as connector manager, which means there are two connections. As you know, inside edit part, I could see go to the connectors. So now I'm taking that approach because the moment I went into the parameters, I couldn't find anything that was allowing me to edit part right there. So now I'm going with the second approach of finding for the connectors. Now I'm going into the connector manager. Now inside connector manager, I get to see we have about 1, 2, 3, 4 properties and one method which is lookup, and it will tell me how many of the connectors do I have. I can see 1 and 2. That's correct. I got the list of two connectors. But okay, and there are, do I have any property that is allowing me to set over here? Shape, utility, press, duct, origin, MEP. Nope, 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 nope. Okay, then let's go ahead with the same. hmm Okay, let's get into the connectors. We'll go to each and every connectors. And there should be something that is gonna allow me. Nope, nope, nope. Yep. And see, the moment you see, there are everything that so far I could see there is no property that seems to be allowing me to change this. But I can see there is another method here that is giving me fabrication connector info, as this is a fabrication ductwork. So it says fabrication connector info. Let's get into this. And the moment I go here, I could see there is a property called body connector ID. How would I know this is the correct one that I need? I have no idea. Let's get into where's edge? Let's get into the edge. Let's go to Revit API. Now Revit API docs. This is also a document which is actually compiled by. It's actually a website which is Revit API docs made by someone else, which is I think GUI Tellerco. I'm not sure. It's not mentioned here. Earlier it used to be here. Anyhow, but the moment you see this is the same part of structure, this is the same structure that I was seeing here, so I'll be able to find the same properties right here as well. So I have to get into a class. These are the something called as class name. If you want a detailed understanding of that as well, just do let me know in the comments, because I'll be more than happy to explain each and every part of what we are going and how we are doing it. But this tutorial, this session that I'm doing right now is for the breakdown, and I'll be breaking it down how I actually solved this problem. So right now we have to get into this class called fabrication connector info. And when I'm saying how I broke it down, I didn't do it alone. As I mentioned in the previous post, Mr. Ratnakar was also there with me. Both of us sat together, did a lot of fun R&D, looking into that, because this fabrication part was entirely new for us. So, but yeah, finally we made it. So now it seems pretty easy. So we'll get into the class called fabrication info. Fabrication part. What was the class name? Fabrication connector info. Fabrication connector info. In this class, I could see there's a property called body connector ID. Now I have to understand, is it a just get property or the set property? And here you go. I can see this is a get and set property. That means I can get the property as well. Along with that, I can set the property as well. But I'm saying property is nothing but the actual name that I'm setting here, right? So let's understand. Right now it is all right, it's set to 93, but how do I set it to none? So that for that as well I need to understand what is the actual ID. And you see the type is for this is integer. Okay, so then let's turn off one of the connector and then we can see it again. I'll snoop the same way again. Before that I'll turn one connector off to get, so that I could get the ID of that particular one connector. I have another ways to get it inside the Revit API as well, inside Python, but rather than that, I'll show you the practical way which will be able to give you the understanding of how it can be done from here itself. So let's get back. Where are we? Fabrication info, get connector manager. Okay, connector manager, where is it? Where is it? connector manager, connectors, fabrication connector info, body connector ID. Okay, you see the first one that I chose is having a body connector ID of. Now you see, now I get to know the difference. Here you see body connector ID is 93, here body connector ID is 0. So that means for each and every connector that I see, each and every fabrication duct that I see, I need to turn the body connector ID to 0. So that is going to be my first step. Let's go ahead with this. So for the time being, I'll select one element only. Then we'll put it into the loop later, which will be very easy. So for the time being, model element. Right now I'm selecting model element, but later we'll be able to get the entire elements from the inside itself. First, select it. Okay, let's select which guy? Someone which is having more than one. Why not let's get with this guy only. Here you go. Now this guy will be having a lot of elements, lot of connectors inside of it. Okay, before that I need to get test. I'll be naming it as fabrication part. This is my fabrication part which I'm getting right now. Okay, I got the fabrication part from the selection which is coming over here. Now what did I do when I was going manually clicking it, going inside, and that's the same way we're gonna do here as well. Let me adjust it a little so that we could see the results as well in the real time. That's the way I like it. All right, so now we have to go each step one at a time. Now I have this element with me. I'll click it, snoop it. What did I do? I snooped it, and after snooping it, I can see there's something called as connector manager, which is somewhere above when I came too early. Yep, connector manager. So I need to call the same property over here as well. So can I say CM, which is connector manager? These are variable namings. So I'll say connector manager on the top of fabrication part. So CV. Now on the top of fabrication part, the moment you wish to call a property or any method, you have to call with a dot. So here we go. I put a dot. The moment I put a dot, after that I need to say the property name. What is the property name? Connector manager, and it should be exactly the same. If you don't want to write it, right click on it, copy it, Control V. Now it will bring you everything, but you only need the property name. Cool, we got the property name. Let's check what is it returning me with. Now it is returning me with a different class called connector manager class. That's what exactly I'll be getting the moment I click on it. Here you go. See, connector manager. I got connector manager precisely. Now where do I have to go? I have to call another property on the top of it, which is connectors. Okay, so can I call it on the top of it? Yes, I can call it right here by saying dot connectors. Here you go. I could see before even I type, I could see auto suggestions as well. So the moment I run it, here you go, I get all the connectors. Is it correct? And the numbering is starting from 0, so I'll be getting actually 11 connectors, right? All right, so I got 11 connectors. Great. Now inside each connector, here we go. Again, here as well, I need to use the for loop. Why do I have to use the for loop? Because this is a list of connector. If I wanted to do each and every single connector, if I want to turn off any single connector at once, I can do that. But now, right now, what do I see is, I see there's a list of connectors. So if it is a list of connector, I cannot do it right here. Because what will happen actually, I'll show you. There's a method called get fabrication part. This is that I want to use. I'll copy it. If you see, I'll call on the top of it dot connector dot fabrication connector info. And one more thing, whenever it's a method, we always need to have round brackets. start and close round bracket, and the moment I hit run, I'll be getting a warning that list object do not have any attribute. See, connector set, which is these set of connectors, do not have any attribute called get fabrication connector info, because this list does not have any method called fabrication info. But if I go inside, and each and every connector, they definitely do have a get fabrication connector info. So what do I do in that case? So the moment I go ahead, I need to use the for loop right here. So what I'll be saying is, so for loop is having a pretty simple syntax. You have to go ahead with for this is connector set. So I'll call it as connector sets. For connector in connector set. The moment I say for connector in connector set, now what I'm doing is I'm iterating over each and every single connector, which means one at a time. Not everyone, not all of them, but one at a time. Right? Now I have access to this fabrication connector info, and I'll say connector dot get fabrication connector info. Right? If you see, now I hit run. Right, just to give me a moment. CM is, yeah, of course. You go, I can get all the connectors. Now also there's an iteration also happening that I didn't put it into the out, but I can, that is actually happening right now. But inside this I'm getting fabrication connector info, which is here FCP, or I'll call it as FCI, fabrication connector info, right? I got fabrication connector info, but from fabrication connector info, my actual thing that I want to get is body connector. Okay, so is equal to FCI dot, I'll copy it from here because I don't want to type it, body connector, and it is a property, so I don't need to go ahead and type. I don't need to use the brackets. So this is body connector. Now this body connector, if I put it to the out, I'll be able to see only one body connector, which is 93. But I can see there are about 11 of them. Why can I not see all of them? So the reason for that particular thing is, whenever I'm looping over the any list, whenever it goes through the iteration, only the last element will be the one that I will be able to see if I just put the rate straight up out. So body connector only remembers the last value, not all of them. So in order for me to remember all the values, if I wish to see, although I don't have to see it, but if I wish to see, then I need to put it into a, I need to append it into a list. So I'll say this is what I did. I created an empty list, right? And then body connectors dot append what. Now I actually want to append each and every body connector. So here you go. Now this is what I'm doing right now is just to show you how a difference it's gonna make. See, now I have 93, 93, 93, all 11 connectors I could see. But what was the requirement? I need to turn each and every connector off, and I need to set the ID to 0. So that means each and every connector should be set to 0. So this is just to show you how you can get it, but now I actually need to change it to 0. And as it was a get property and a set property, right now what did I do is, this is the way I got the property, but now is the time to set the property. So how do we go ahead and set the property? Set property is very easy. You just have to go ahead with the assignment operator, and that's it. What is assignment operator? Equal to is the assignment operator. So now I'll say from these guys, I'll remove this part because we don't need to go ahead with this now. I'll simply say body connector ID is equal to, and if you know, the storage type is integer, or the return type is also integer, so it will take 0. Now I'm setting it to this, and I don't even need to see this. but now you will be actually able to see the difference that will be happening right over here the moment I'll be hitting done. All right, let me close all of this first and I'll hit run. Okay, so the moment I hit run, first of all, there's no list is called connectors. Let's hit run. Oh yeah, go. Here we go. We got a proper. We have an exception. Ah, come on. Yeah, I forgot to tell you guys this. What we are doing here is whenever you wish to make a change inside this model. What do I mean by change? Because this is some physical change that I'm actually making inside this model. So whenever you make a change, there has to be a particular, I would say, a set of rules that are meant to be followed. And what sort of rule I mean in this case is the every change, and I could give you a banking transaction, right? Example of banking. Whenever you deposit money or whenever you withdraw money, it is considered as a transaction, and your all your amount, all your account will be open for a certain amount of time, and it will be opened and change will be made and it will be closed back, right? So that it keeps secure. That's how Revit API also keeps the same provision on the top of it, where if you wish to make a change into the model, every change should go through transaction only. If it is not in the transaction, it will not let you make the change over there. So how can I make a transaction? It's already there in my model, in my code. All I need to do is put this guy over here, which is all right. Now if I hit run, there you go. Instantly, all all of the connectors are turned off. So that's done, which means, can I simply say we successfully managed to we successfully managed to do this. Done. The first part done. What else? Now to go ahead with the smart parametric flange family. Okay, very good, very easy. But yeah, I'll show you the family. I'll place it right here. We have this family, and I'll not be going into the depth of the family because there are multiple tutorials that you can see around the YouTube as well. And this is gonna be entirely about the Revit API and how we can automate it. So this is the family that we have made. I'll show you what was the thought behind it. We actually made a family which is face based. This is a face based family, right? And this face based family is having some parameters inside of it, which makes it entirely smart, or I would say parametric. That is the precise word, which is parametric. So all the dias that are supposed to be there, although we could have used some different ways, but we did not want it to have some external dependencies or anything. So to keep sure we have this family working at all point of times, we have set everything inside this family itself, and now this family is entirely independent. It doesn't need anything else. So the moment the dia will be set, the number of holes, the number of bolts will be changed according to the parameters that are given inside here, inside the properties. So that's all about family. So with family is also there with us, and you can, if you guys need this family, let me know. I could drop it in the I'll try to drop it in some OneDrive or some way. I'll try to make sure you get it if you want it, right? All right, so now can I say this guy is done? Check. Done. Now is the toughest part. I won't call it toughest, but yeah, this is quite tricky to have hold of this. So let's just go ahead with it. This is already done. And one more thing, now this is done for one guy only. What if I wish to do all of these at once? What can I do in that case? Then I have a very special and I would say sweet class, which is filtered element collector, which is one of the class that comes from Revit API. I'll show you right here. Filtered element collector. Here you go. Filtered element collector. We have some constructors which will allow me to make the instance of this guy, but just by saying the name of the class and giving some inputs, which is a document that I already have it available with me over here. So let's just get into that first. Yes. Now What do I need to do? Right now, I can actually select all the duct parts that I'm having right now. All of it, I can select it, and just by selecting it, I can turn the fabrications off. I'll go ahead with the same. First of all, I'll say all fab, all of the fabrication parts that I'm having. And how am I going to collect it? By using filtered element collector that I copied there. Filtered element collector. It needs, for me to instantiate the instance of this filtered element collector, I need to say document. The moment I say document, now all fab filter element collector is instantiated, right? When the filter element collector is instantiated, on the top of it I have some filters that I can use to specifically collect everything from my document for only for the classes that I want. Now, to understand first, what is the class name of these guys? The class name is fabrication part. Okay, seems easy. So if the class name is there, if you see here, we have a method called, you go, you have a method called of class, right? There's a method called of class, which needs type, and type is nothing, the class name for the time being. So I can use this method called of class. Okay, let's go ahead and use it. On the top of it, I can say dot of class, and after that I have to pass the class name. Class name I already showed, which is called fabrication part. So I can say fabrication part. And yeah, in the meantime, along with the collection itself, along with the task, I'll keep on tweaking the code to make it even little better. So please keep eye on that as well. So after that, now I'll be able to collect all the fabrication parts, which you can see here. I got all the fabrication part, which is about, in my model I'm having how much? Let me see. I think I have around 11 of them. 11 fabrication parts are there. Okay, from these 11 fabrication parts, which you see right here is, what you see right here is the format of class representation. But if I wish to see in a particular representation of the elements, then on the top of it I can say dot to elements, which is one of the method that is available from the filter element collector. Here you go. Now I can see there are actually 11 fabrication parts available in my model right now. Okay, very well. And now what I have to do is, I want to have the same change that I was doing, but for the all of the elements at once. By at once means it will be happening one by one inside the loop itself. The moment you have to it run once, and all of it will be changed. So now what we did from FP, I'll do not need it. I'll take it out of here. I'll keep it somewhere around here. Right? This is somewhere there because I don't need it that right now. I don't even need this guy. We'll use this for you will use this input for something better. Okay, now the point is, this is the list that I want to have one at a time, and after that I want to turn off each and every connector which is going ahead with the same process, right? So I need to put this entire thing into the loop, right? So how do you go ahead with the loop? We already saw how the loop is instantiated, right? How do we go ahead with the loop? So we'll simply say for what? For fabrication, which is fab means cool as well. For fab in all fab, what do I want to do? I want to get the connector set. How will I get the connector set? By saying fab dot connector manager, but here I'm saying FP because I need to say fab dot connector manager dot connector. It will give me the connector set. Then I need to go ahead and get loop it on the connector sets. Okay, so that means, first of all, let me bring this guy up. Okay, now to make right now this loop and this loop, everything is independent because this is not part of this loop. For me to make this entire piece of code part of this guy, I need to put the tab, I need to hit tab, which will give a indentation. There you go. Indentation is a technical term for this spacing that I have just given right here, for all this code to be part of this loop. Okay, now if we are done, then let me take this back. let me take all the nano scripts that we have run so far. Let's take it back. We are good so far and everything is good. Then if I hit run, it should turn each and every connector that I could see over here to 0 value, which is connector should be off. Let's try to hit run and voila. There you go. Each and every connector that was there already now is set to 0. Now if I snoop any one of it, you could see connector manager. Inside that connector will have fabrication connector info. Every connector body connector ID will be 0. For the other guy also, you see body connector ID will be 0 because that's what we have set. We have set it to 0 for all of it. Done. We successfully managed to have one set of code done and dusted. First part done. Now second part we have already seen. It's working for single and multiple. Now we are done with it. So now any number of fabrication part that will come inside my project will always be turned to 0 the moment the script will be run. Okay, so I'll try to keep two different transactions. I'll close it right here. I'll keep this piece of code over here. Yes, so this one part of code is done. I'll put some comments over here for you guys to understand. I'll just copy this, which is this guy only. I have access to this. Turn off every connector. By setting body connector ID to 0. And yeah, the moment you put hashtag, it turns like a comment, which is a non-executable piece of code. Alright, so one part done and dusted. Now is the time to go ahead with the second one. Now we'll keep this single guy because still we have use of it, right? Why I'm saying use of it, you'll get to know. So now I want to go ahead and work with the second part, which is gonna be to get the face from this guy, and after getting the face I want to actually place the particular family that I'm having on the top of it. So what do I do in that case? I need to make a selection which will be for the particular faces, because if you see user, I actually can get the faces from inside as well, but I want to give this access to the user. That's where I want to make a particular filter which will allow the user to select the faces that will be coming from the duct part. So in order to do that, I'll there's a special class over here which is coming from selection. Come down, and this selection you will see there is something called as there's a special class inside this called selection class. Inside this selection I have some methods which is like pick object. It says pick object. The moment I click on this, I can use this object and it will returning me with the reference class. Okay, let's go ahead and try to use it. Pick object, but it is coming from a class autodesk.revit.ui. Do I have it with in my code? Yeah, I do. Revit UI is there. So from that Revit UI, I have got the app document, which is a UI.document, which is UI doc. So on the top of it, I need to say, let's just say faces is equal to UI doc dot pick object, and from this pick object, I need to say all the faces that I want. I'll say how do we go ahead with it? It just need one, which is object type. It is actually having multiple ways to construct this, but for the time being I'll be going ahead with the first one, which is just asking for object type, and then I'll be showing you why this is something that I do not want to go with, because that is where this guy will come into the picture, where I mentioned about the Control Z, then this guy will come filters for selection. This is the second part which will be integrating, but yeah, right now you should understand why this filter will be needed, right? So that is the case. I'm going ahead with the simple filter first, simple selection first. I'll go ahead with pick object. And it needs the object type. So in object type, what is object type? First of all, we need to understand object type is nothing but it says specify the object type that I wish to select, right? So in order to understand that, I need to have this object type. What is this object type? That should be the first question, because right now if you see, this object type is nothing but it's an enumeration. You see, it will tell you what is exactly that you're looking for. If I say nothing, it will not select anything. If I say element, it will only select the element. But in this case, I don't want, because I don't want element, I don't want linked element, I want sub element, I don't want edge. Something that I want in particular is the faces. Why do I need face? Because I have a face based family that I want to place onto that face. So in this case, object type dot face. Let's get back here. I'll say same object type dot. Now I'll get the same dialog box from which I can choose what do I want to get into this my selection, what I want to bring in into my selection. I'll say face. Okay, I got it. Is it over? Is it all done? Let's try to hit run and we'll get to know. Let's hit run. There is something wrong. It says pick object has no attribute. What attribute? UI doc has no attribute called. Why is that so? Because UI, it is coming from after UI doc. Here you go. After UI doc, we have a selection. It is coming from selection class. After UI doc, into say selection, UI doc dot selection, then pick object. The moment I hit run now, I will have a dedicated selection right over here. Let's hit run. Here you go. Can you see this? On the bottom left, you can see. Let me close it for you guys. On the bottom left, it says click to select a face, tab for alternates, escape for quit. Okay, you see, now I can select it. But you see, only I can select the faces now. If I try to select this element, I will not be able to. So these are the actual faces that I need. You see this? Moment I come here, this is my face. You can see this blue part, right? These are the faces that I really need. Here you go. So if can I select it? Can I snoop it like this? No, I cannot, because I have used a method called pick object. You see this? The method that I have used is pick object. But if I say there's another method, you see, we use pick object. Now there's another method called pick objects. So this guy is letting me and allowing me to select only one face at a time. Here you go. If you see the faces, I should have got it here. Let me select it again. Here you go. You can see autodesk.db reference. Why reference? Because that is what the return type is, right? Now I don't wanna use this. This is very good when I am getting only one face, right? I got one face. On the top of it, I can actually place something, which for the timing will keep pick object only. Then I'll change it to pick objects. So the time you can understand when we are having one face, how do we actually place a family over there, right? And here I kept this. Along with that, I can give one more thing. You see, if I wish to say something particular to the user, that select particular, I can give the prompt to the user that you have to do this and this will happen. So I can say to the user, make a selection. I'm giving the prompt for the pick objects. For the timing, it will giving me, right now I'm selecting one only, but I'm giving the prompt for the multiple selection. Make a rectangular selection for selecting elements. Okay, now you see the difference. Earlier I could see just one thing. Now if I hit run, can you see, read it at the bottom? Make a rectangular selection for selecting elements. This is something that user were not able to see earlier, but now he can do it. But for the timing, we have used pick object, so we'll select one element. Done. We got it. Now we have a reference. We need to use this reference, and inside this reference will give me some things. Pick objects. Done. Now we got a reference. Inside this, we got a reference. Now, what is this reference gonna do? What is this reference is gonna allow me? So now there's a separate class called reference class, because this is the return type of it. So I'll say reference class. Now reference class is having some property. It will give me the actual element ID of the reference that is coming to me, right? So I'll say I want this element ID. If you see, I got this face. On the top of it I say dot element ID and I hit run. Again I have to select code. That selection will be coming on every time. 323711. This is the element ID, which is actually the element ID of this element only. See, 323711. But yeah, I got this element ID. I can say doc dot get element. Now inside this I can actually pass the element ID that I got earlier by saying dot element ID, or I can actually give the reference as well, which is coming with me from the face, right? The moment I hit run, now I'll have the actual element, which is this fabrication part that I got, right? Now from this fabrication part, on the top of this element there will be a property, or actually a method. Now I got this element, right? Let me go to the element class now. Inside this element there's gonna be a method which will be allowing me to get the, here you go, hey, yes, retrieve one geometric primitive contained in the element given as a reference. You see this? I need to have this actual geometric object. In this case it will be a particular face that I have selected, right? So on the top of this I'll use this dot get geometric reference, and again this guy also I need to pass the same reference for the same reference that I'm getting from here. The moment I hit run, I need to select again. I got the actual planar face that I was looking for, because this face, this planar face, is what is of major use to me. I do not need the actual element, I need the face. Now I got this face. From this face I can actually get the lines of this, right? Why do I need lines? I'll show you again why do I need these lines. But before that, because this face is not actually giving me the location where I need to place it, right? And along with this, when I have this element, these elements could actually have a simple different transform as well, where these elements could be placed at a location, but their location by Revit API, if I go ahead and select, might be showing something else. So that is what we call transformation. So I have to apply the transformation on the top of it to have them on the actual location. I'll show you how we're gonna do this. Okay. So now we got this guy. So I'll call it as planar face. Yep, we got the planar face. Now from this planar face, let me get the lines out of it. How do I get the lines out of this planar face? Now we are getting a something called planar face. So what I'm getting, I should go into this and I need to look for the same class first. Planar face. There's a class called planar face, which is a bounded 3D solid or an open shell, which is exactly the face we have right now. Now this guy is having a method called get edges as the curve loops. What do I mean by curve loops? Curve loops are nothing but the faces, actually, the lines around it. Now what do I have to do? I need to get the lines out of it. Let's write the same. For the time being, if I go ahead and call the, if you see plane face, on the top of it I know there's a method that we just saw, which was get edges as curve loops. Here you go. If I put this lines out, I'll be able to get this two arcs. I got two arcs, and these arcs also, if you see, this itself is a list of arcs, not just single, it's a list of arcs, right? So can I say I just need the first list, which will be these two arcs itself, right? Because there could be multiple faces itself, multiple lines, multiple edge arrays could be there, right? Now I need the, I got the two arcs. Done. Out of this, what do I need to do? I need to just have single one, which will be fine for me to have an understanding of it. I'll just get it. And now on the top of it, if I try to snoop it, if I try to do this indexing again, I will not be able to do it. It will give me the warning because this is an unindexable object. So the return type that I'm getting from this is cannot be indexed. It's an edge array. So for me to convert this edge array into a list, I can put the list on the top of it, which is what we call typecasting. So now I'll be able to get the what is it? Yeah, sorry, list. There you go. Now I can actually get the single arc out of it, right? Done. I got this arc. Now, and for the people who if it's getting too overwhelming, I can understand this is how we actually break down problems into the small steps, right? And the last part was the bigger chunk. I can assure you that. And right now it's even we're gonna even refine it even more. So if you don't understand any part, if you get to think that it is too much of it, try to take some break, come back again, totally all right. And if you still feel it's too much, let me know how I can improve with the way of explanations even better. Comment section is completely wide open for you. And if you guys still here till this time, you have managed to see it this much, then I would say please go ahead and subscribe it as well, right? The Indian BIM guy, go ahead, subscribe it, and let's just get it. Now, right now I'm getting it as an arc. Now there might be a possibility. I'll show you what good possibilities could be. In this case, I'm getting an arc, but if you see, if I get the face of this guy, which is this square guy, and I know this face of square guy needs to be avoided. If a user selects this, now if they get the edge loops or whatever they get, now these edge arrays will not be the arcs. Now these will be the lines. If you see, the edge arrays of the previous guys were not, those were not the lines, those were the arcs. But now I'm getting this as a square, so that means I need to avoid this. So in order for me to avoid it, I'll be writing just pretty simple if condition, which will be saying if is instance, it's a inbuilt Python method, is instance, which checks particularly whatever I will be giving, it will the input will come from here, which will be line. Now it's again input, which will be what is the class I want to check it for. I want to check if it is arc, then I want to do something. If it's not, let it be. So now if it is arc, I actually want to, I'll show you actually how this arc is coming first. Let me comment it first. Single line only, right? Let's put a single comment. Okay, now I got this arc here, right? I'll show you how I can, I'll change it to dot to prototype. This prototype will give you the understanding to have an visualization of the actual arc that we are selecting, and I'll be showing you it. If I am right, it will be going at some other place. Yep, that's what I said. You see, I selected it right here. I have selected this face, but this face arc is going over here. Is this correct? Obviously not. Is it just with this face? Let's try with some other guy. Let's try this. Now, where is this guy? You see, here you go. I've selected this face, which is over here, but this face is showing me over here. So that means this needs to be transformed. It needs to be sent back to this place. That's where we see there's a transform inside this. Here you go. See, there's a method called get transform. So using this transform, it will show you the origin. So this will be the actual change, or I would say you can actually have an understanding if there's a difference with the original location or not. So in this case, it is there. How do I send it back? Come on, let's try. Let's try to send this guy to its actual location. We'll manage to do it for sure. Okay, now what I want to do, I want to check if his instance arc. Then I want to apply a transform on top of it. First, I'll get the transform from this actual element that I'm having, right? How do I get it? I got the element which was where is it? Did I not store the element? Okay, I'll store the element as well. I actually called this property on the top of it directly, but let's store the element also before this. I need this element just for this purpose. Otherwise, I don't. I could actually avoid that as well. So Control X, Control V. I'll put this element. I'll call it here. Yes. Now I need this element dot get transform. The moment I get transform from this guy, I will be having a class called autodesk.revit.db.transform. Now let's go ahead with the next step. What would be the next step? I'll get the transform, but this transform needs to be applied on the top of something. And if you know, this transform can be applied on the top of, here you go. Transform can be applied on the top of points of vector, but I cannot directly apply on the geometry. What do I do in this case? We have to find solution. We will make sure we'll find it. Okay, so how do you go ahead? I'll make a variable called cp is equal to, which is center point. I'm actually getting the center point of the same. So planar face dot evaluate. After evaluating, here you go. There's a method called evaluate. How do I know? I know because I already worked on it, but I'll show you how is it coming from. Planar face is having a method called evaluate. Let me go back, which takes parameters in form of uv. U or v is nothing but the xyz coordinates we can have an understanding, right? So if you see the parameter to be evaluated, then in the natural parameterization of the face, so we have to give it in the form of uv. But now if we have to give it in the form of uv, but first we need to see what actually uv is. Uv itself is a class which can be constructed by simply like this itself, right? If I give this itself, it will be created as default 00. That's all right. I'm totally all right with that. So we can say uv done. Now I'll have something called cp. Let me put this cp here, and for visualization we'll say dot to point. Okay, let's hit run. I'll select this face. Here you go. Now that same thing is coming at the same place. Okay, let me before that, I think I removed this planar face, right? Nope, I'll keep this also, so that you could understand better how did we got the center point. To prototype, let's hit run again. Here you go, we got the center point, right? We got the center point. Now if we have the center point, what do we do? Now actually I can provide the translation to that guy, right? What I'll do in this case is, let's provide the translation to the same. pp is equal to, it'll be new point, transform, which I have stored over here. I already know how much to be transformed. Transform to dot of point. How do I know of point? Because there's a method here which was transform dot of point. As I told you, transform can be applied to only few things. In this case, I can use of point as well. I have the point with me. Transform dot of point. And what is the point that I want to transform? I want to transform this point, which is cp. Okay, now this point will be transformed. Pretty all right. Let's see if it gets transformed here. I'll call it as pp rather than cp. Now let's select the face again. Here you go. Do you see this? We are right now, you see I'm sending out three things. First is the line, which was this one, which is coming actually wrong. It should not be here. But now this is the point that was at the wrong place, but I need to have it at the correct place, which is gonna be my placement point, right? This is right where I wish to place my new family, right? Now I got the placement point by translating it here. You see, this is the line that I'm getting here. Then after that, I'm getting the CP, which is the center point here. Now I've got a PP, which is placement point in this case. Now I'm translating, I transform that point from here to actual placement point by applying a transformation on the top of it. That means I got the transformation of the actual placement point. Now this will be the point that I'll be using for my placement. But if I'll be using this point, what other things do I need for actual family placement? And to place a family, we have a special class called new family instance class. And you see, in this new family instance method, I have a lot of method, but I need something which will be the face based only. Okay, totally fine. So in this case, I can see this one seems good to me. It inserts a new instance family onto face existing element using a location. I have the location. Face, I'm having reference direction. I need to have. I'll get the reference direction, not an issue. And then done. That means I can use this method. Let's take this method into this. I'll keep it here. I'll keep it commented here. Okay, let's try to go ahead with this now. Now this is almost our final step, but we have to add some finishing touches on the top of it that I'll be adding in some time. Just give me some time. Now on the top of it, now I have placement point, but also I need a reference direction. So I'll call it as RD. Reference direction, how would I get the reference direction? Reference direction will also be coming. Actually, the reference direction I can get from, I would say, directly from this planar face itself, which will be, if you see planar face dot, it will have a, I'll show you how do I get it. Snoop face, click it. Okay, come here. You see, this will have a vector. I can use this x vector, which is fine for me. I'll say dot x vector, but also I would like, oh sorry, this was a property. Also, I would like to apply the transformation on this vector as well. Dot of vector, because this will give me a problem if I don't. Of vector, then I'll give this guy as vector, and now this will be transformed. Done. So I have all the things. I got my face, which was about reference. Where is this reference? Yeah, which will be coming from the here where I'll be getting the references. But right now I'll getting face from here, which is actually my reference itself. I can get this, use that face. Okay, I have it. Then I need the location XYZ, which is my placement point. Then I need reference direction. I have it done. Then I need symbol. What is family symbol? Family symbol is nothing but the what type I wish to use it. So I'll say I can take it from here. Why I'm here taking it from here is so that user could also have the control to which family to be placed. I'll use family types from here. What was the family name that we have placed somewhere here? Let me get it here again. This is flange face based. Flange face based. Here you go. Now I'll take this guy as an input from here, which will be FS family symbol 1. Now I have the family symbol as well with me. So that means if I have everything, now I'm good to go to place the new family instance. I can create here itself, and along with that I mentioned something earlier. If I need to make a change inside the model, I need to have the transaction over there. I'll put the transaction here. Now in this transaction I need to have the same C, Control V. I'll be placing it in between these lines. Now I need to create a new guy, which will be new flange ff is equal to, what will it be? First of all, in order for me to create a new family instance, this is coming from a class called creation namespace. So I have to say doc.create, then doc.create, sorry, it's a method dot new, what is this method name? Here we go, we have it right here, new family instance. Then on the top of it I need to say the face. Where's my face? Face, I already got it, which is coming from here for the timing. Then I need the location, which is my placement point. Yes, I have it. Done. Then what do I need? Then I need the reference direction. Yes, that too I have. Then I need family symbol, which is fs over here. If everything is correct, we should be managed to create a new flange, but we will not be able to. The reason we'll not be able to is right now we'll be able to, because this actual flange is placed. If I delete it, let's hit run first, then we'll be able to go ahead and see. Save, sorry, hit run. Let's select this face now, and here you go. Do you see? The new flange is placed. But yes, this is not done yet, because if you see, if I selected this, it got placed here. But let me try to do it again. You'll understand the difference why I'm saying it's not done yet. Now if I select here, again it placed the same flanges. That means the parameter will also be need to set. And how do we set the parameter? Because we didn't get the dia, or we didn't get any understanding from it right now, right? So that I'll show you in the meantime. Before that, now this is all good till the time I'm going ahead with the one reference. But I know this is not the method that I want to use. I want to use a method called pick objects. If I wanted to do one by one, I would have done it manually. We want to do it multiple times, multiple at a time. Now I'll say faces. This will give me actually faces. Now it will give me a list of faces, list of references. So again I need to put this guy into the loop. So I'll say for references in faces. Faces will give me list of references. Then what can I do? Can I put everything inside the loop? Here you go. Tab. But here we need to make some changes. Wherever I mentioned face, I need to put reference. Sorry. Here you go, reference. Tuck. And here as well I need to put reference. Okay, seems like it could work if I have not missed anything. Anyhow, let's try to hit run. We'll get to know. But yes, now you see, let's hit run. It's giving me, you see, this was not there earlier. Now I have a option to select finish, cancel, and select multiple and all. But you see, it is allowing me to select faces. You see, it even only the faces are being selected. Can you see that? Let me hit run again. If you see this, I can make a rectangular selection, but only the faces are being selected. Do you see? Only this guy's faces are selected, right? Along with that, I can have this also. Only the faces will be selected. If you want to see it, how it works precisely, you should see with this guy. How many faces are there? But only the faces will be selected. Nothing else will be selected. But here as well, I have one loop, which I mean, if I say loop, it's actually limitation right now, because right now if I go ahead and snoop everything, if I select everything, it will bring in the, you see, it will bring in the level also. You see this? Here you go. Do you see this? These faces are also being selected. I definitely don't want that. I'll show you how it's happening. You see this? If I'm selecting this, this is also being selected. Come on, I don't want that. How will I be able to place the family here, right? This is one of the limitation, where for that specific reason I mentioned a filter for selection. Now I have to make a specific filter that I'll make. Just give me a moment. So first we'll show you how multiple families will be placed right here. I'll try to avoid it by going into the plan. I hope I'll be able to avoid it. Yes, let's try to select it here. I hope I have avoided it. And now I'll finish it. And yes, I managed to do it correct. I did not select this. So here you go. At every place, wherever this was there, one of this at the same in the same orientations, you see how many of these are placed here. If I select all, about 33 flanges I have placed. But here as well, if you see the limitation, what limitation I mentioned right now, what we are doing is we haven't set the parameters to these guys for the diameter. We'll set it, just give it a hold. But before that, I need to solve one more problem, which was this selection. I don't want, see, I'm giving user the freedom to choose on its own. User might choose it like this, and if this face will come in if this thing will come in between, it might give the hindrance, and it makes the experience not up to the mark, I would say, right? So if I have to go ahead and avoid that thing, now I'll be writing my own filter class, which will be specially a new class that I'll be writing, which comes from same namespace, which is selection namespace, but it is actually an interface, ISelection interface, which gives me and gives me two methods, allow element and allow reference. In allow reference, I can actually define what are the things I can allow to pass, and what are the things in allow element I'll be saying what are the elements I want to pass that filter. Let's see, let's get into this. So for this, let me create the class. Yep. I like this part the most, because the user get the more customized experience to select only the things that they want to have, right? So let's go ahead with this. How do we make a class? By simply saying class, I'll call it as my duct filter. Yeah, that's fine. Then you go ahead and say this, and inside this I need to pass the interface. This interface is ISelectionFilter. I'll copy this name. Then what I'm doing by saying this is that only the method that are allowed by this guy coming from this interface, it's actually like a contract, I would say. This rules supposed to be there on the top of it, then only this will work. So I have inside this I have to say definitions, and inside definition I have two methods already that are coming from the interface, ISelection interface, which is allow element. First is allow element, and whenever you make a definition inside the class, we always have to say self. It's the first argument we have to pass, self, then the actual element. Okay, then I'll say if condition. What do I really want to come into my selection? I don't want other things to come into my selection, right? So I'll say element dot category, then dot name, right? What do I want to say? I want it to have only particular category. I know the category that I want right now, which is MEP fabrication. I could actually just enumerate it with the actual category as well, but I'll go ahead with the name. Ductwork, right? This is done. Now, if this is done, then only return true. Otherwise, I don't want it in my selection. Return true. Otherwise, return false. Done. One, there are two methods inside it. First, I already used. I need to use another one, which will say if there's that face is an actual face. There might be possibilities I could get some what do I say, invalid elements or invalid items as well, right? So I'll say allow reference. Inside this, I need to again pass the first element, first reference as self. Then I need to pass the, if you see, allow reference first self, that is because of the Python terminology. Then I need to pass a reference, and I need to pass the position, which will be point. Okay, first I need to give the reference. I'll say reference, and then I'll say point duct, just that's it. Done. Now I need to return reference dot element id. Now I'll be saying if it is not equal to actual element id, then I don't want it, right? Because there might be possibility that some element ids gets generated which are not actual valid, right? There could be invalid element ids. So if it is an invalid element id that is coming to me, it will never be coming to me inside this code. So I'll say element dot, and element is having a property called invalid element id. Yes. So if we are done, then I think our class is ready. So if the class is ready, I need to have an instance of this class. So I'll say filter is equal to my.filter, and again I don't need any input inside this to instantiate it, but now I have my filter instantiated. Now how can I use this filter? Because my selection is being driven by faces. My selection is being driven by this guy, right? Pick object. But if you know, in this pick object, selection filter, where is it? Selection. Selection class. You see, I have used pick objects, and I told you this pick objects is having 1, 2, 3, 4 multiple, and there is a way where I can pass ISelectionFilter as well. So that means right here I can pass the ISelectionFilter, right? So if I go ahead, first argument is already there, third one is already there, and I need to put one more input inside this, which is right now my filter that I have just created. Done. So if that is correct, if it is working correct, then let's see the exception that we were having earlier. It should not come. Let me undo it. So now you remember earlier I was selecting this guy and this was getting selected. Now let's try to hit run, and the moment we saw earlier that we were getting this guy also into the selection. Let's see if it is getting selected now or not, because we have successfully managed to make our own filter, which is this guy, and we have applied this filter on the top of pick objects, which is over here. Let's try to hit run. Here you go. I can get the same thing which I was getting earlier. Finish selection, everything, and I can select this going fine. But is this guy coming into my filter or not? That's the point. Earlier I was getting this also into the filter. You see, now see, I'm getting everything, but that is, so now the user have flexibility to make a selection no matter how wider it widths to, but it will get faces only from the category that we have mentioned over here in our default filter in our class, which is MEP fabrication ductwork. Otherwise it will not get anything else. Yes, you get this? I hope this makes a difference, because this definitely made our life easy. So now I select everything, but only the faces coming from MEP fabrication ductwork will be coming to me. Let's click finish. There you go. All of it got generated, and we successfully dodged to create this, to avoid this square guy, because of course if I want to place this family we have to write separate thing. But yeah, I successfully managed to create the ISelectionFilter, and we successfully managed to dodge this square guy as well. It's working fine so far. Okay, we'll delete everything. Done. So I think we have successfully managed to do this much part where we can create each and every family, and it's pretty easy. But now what major part left is to successfully have our dia to be on the top of each family, right? That is the part that I need to create right now, that we need to take care of, which is pretty small, and I'll show you that right out here because of where you could actually have the visualization as well. So for that I need to take some things out of here. which I'll be putting out. What do I need? I'll take some loop points from here itself. Integrate inside transaction itself. Loop points is equal to, how do I need it? I need the points for from the planar face, which is planar face. I'll create an empty list. That would actually be better for me. Loop points is equal to an empty list, and I'll take some points outside, which will help me to create the, I'll actually not the take the points out, I'll take some things out which will allow me to get the, because now I have this face which is having this edge curves, so I need to get the dia of it. So for that I'm taking few things out. I'll say loop points dot append loop points dot append. If I say loop points dot append, then I need to append some things that I want to take out from there. First thing I want to take out is planar face, but I don't want it like this. I want to see it in the dynamo geometry. So I'll say dot to prototype. Dot to prototype is the way I can convert it into the particularly visualization for the dynamo. Now if I'll be going ahead with this will be coming as a list. So I'll convert it into a first element only. Done. Then I need something called as the new element that I have created. These are the new elements that I have just created. So I'll get these new elements as well, which is new ff, and I need to get append this, but if you see, append only take one argument, so I cannot give two. So I can convert it into a list, and now I'll be able to get it out. Now let's get this loop points list out from here, and if we are done, managed to do it correct, then I should be able to see. Yes, I think that seems pretty much enough for me to work in Python. Now I'll show you something from the in terms of visualization that you'll be able to see outside here. Let's hit run. I already did undo it, so let's run it again. I'll select everything again. If you see how easy is it right now for me to select, because I'll not get anything extra. I will not even be able to get anything extra which is not the particular element that I'm looking for or particular phase that I'm looking for. And that is done. If selection is done, I need to finish it. Done. Here you go. You see, as I mentioned earlier, all of these are having transforms which are coming at the wrong location, which is where you can see the faces here. Let me show you at the back. These are the actual planar faces that I got from each and every selection that I had right now. See this? Although I don't care how many of this is coming, and even if the location is wrong, because actual location we have already got it, we have placed the family as well, so that doesn't make a difference anymore to me. So what I'm gonna do is, now with the help of these faces, we'll be extracting few data. What data I need? Now only one thing that is left out of our workflow is that is for us to get the from this surface to get the dia out of it. So I can actually get it, dia or radius, whatever you call it. So I think I'm done with here. I'll no need to write anything here. Major part of code is done. Now it's just pretty small thing that's left. Now we're done with this. What do we need to do earlier from now on is I need to transpose this list, because this is two things. I'll transpose it. I need two separate lists out of here. Here you go. Now I have two separate lists. First is of surfaces and second is of, I'll turn this preview off. Now first is surfaces and second are actual new flanges that we have just created. Done. What else do I need? I actually need only surfaces to get the dia. I'll say, so from this I can actually index it A0, because A0 is my surface list, right? Now I'll get only the list of surfaces. Here you go. These are only the surfaces. From these surfaces, I have a particular one which will give me the parameter curves. Surfaces, I can just write. I need only parameter curves. There you go. I got the parameter curves from the surface. And let's hit run. You see this? I got parameter curves right here. Do you see this? This is the reason I wanted to bring you into Dynamo back to show you the visualization part of it, how we actually manage the problem, right? Now I can actually have it here. Now I'll simply flatten it because I don't need to have it all. I'll flatten it. What flatten does is it gives you the single list out of multiple. So you can flatten it to any extent using the amount. Done. We got all the circles. Now if you see in this circle, I have a property. Here you go, circle point radius. There's a property called radius. Okay, now let's get the radius. You see, radius from circle. Circle dot radius will give me this radius. Do you see at the back? I like this. It looks good to me. Anyhow, let's come back. I got the radiuses, but now radiuses are in terms of decimals. So let's use one more node to round it up. Not round it up, just to round it. It will round it to the actual 250 and 100. Done. Now these are radius, but this guy that we have over here is having a parameter for diameter. So how do we convert radius into diameter? Not a big science. Just a cross 2. Not that a, buddy. There you go. Now we have it. We got the dia. If we got the dia, what else are we left with? That's it. That's what we are looking for, right? We got the dia. Now all I need to do is set it. And I'm sure all the people who are looking these videos, who are watching this video right now, must already know which node do we need to use right now. Pretty easy. Set parameter. There you go. Let's get this. This is the parameter, and the parameter name will write it. These are the element. Where's the element? I didn't get it. So I need to get this guy. I'll copy it. This guy will go to the elements, and now I need to pass the parameter name. In this case, the parameter name is you go diameter. Let's hit here and diameter. Done. So if we had done, let's hit run. What happened? What happened? What happened? Okay, parameter name, diameter, what is it? I think we have given something wrong, I guess. Yep, exactly. I didn't change it to 1. Done. Let's hit run. There you go. Each and every parameter is set. Along with not just that, if you remember, our family was completely parametric. So you see, the number of bolts also adjusted, and each and every family is placed precisely at its location with diameter being set and the number of bolts automatically set. And that was the main intent of this video, right? To get to this understanding where we could actually manage to break this problem down into pieces and finally come to a conclusion where we could easily do this work, which was about, if I try to do this manually, right now these are about 11. There could be multiple of them in their workflow. So if they try to do it manually, it could take them easily an hour to maybe more than that. Maybe they might be spending their entire day on this, if depending on the number of it and depending on the task complexity. But yeah, what does it take now? Let's see and run it one more time from the scratch. And now to make it look good, we can group it and we can do all of the things. That's totally all right. All of you already know that. So yes, let's save the script. I'll save it. Done. I'll save it with some good name. Let's save it as video 2 for what? CAM-Duct. CAM-Duct 2. Done. Here you go. We are done with it. And now let's hide the visualization. I don't need it, although I like it. But yes, congratulations. We successfully managed to do the entire task in just what it took about 1 hour to write for the time being. And although after these explanations and all, but if I go ahead and try to run it again, let's do it one more time. Why not? Let me undo it one more time. Here you go. Now I do not have anything. Let's open this again. Let's hit run. It will ask for the same selection. I selected it, and after selecting it, if you see, it is going to be a matter of seconds. And done. Here you go. Everything is done and dusted. That's it. That's all it takes to automate your workflow, and that's what I promised to you guys. If you have certain workflows that you are stuck with and you think that can be easily automated, and if you are not even aware that can be automated or not, totally fine. Drop some comments down there and I will make sure to visit that. And before you leave, before that, I would like to take you to some place where we should definitely connect, right? Come here, make sure to connect with this guy, and I'm sure you already know who this guy is. This is the Indian BIM guy, aka Bharat Minocha as well, right? So go ahead, hit subscribe, and if you liked it, and I am pretty new to YouTube, so I don't know how to do these things, but I'll still say go ahead, like, subscribe, share, whatever you wish to do. But make sure you do comment to have your workflow sorted on this channel itself, right? As I mentioned in the beginning as well, the moment you saw the first video itself, I mentioned this is not my YouTube channel, it's going to be yours, right? So you can drop your workflow problems and I'll be automating it right in front of you. And if you want me to have it solved in some live stream, let me know. I'll host a live stream where you can actually join and we can solve it together, right? So make sure you connect with this guy. Let's get connected, and along with that, make sure to subscribe. That's all I can say, and I don't know how to end it, but yeah, thanks for watching. I'll see you guys in the next video. Bye bye.